Average acceleration. It is the ratio of change in velocity to the time interval in which this change occurs. Hence, average acceleration equals to change in velocity divided by time interval, or a vector average equal to average vector A equals to delta V by delta t. Also, it can be written as V2 minus V1 vector divided by V2 minus T1. Instantaneous acceleration. It is the change in velocity at a particular time instant, that is a vector equals to limit delta tends to 0 delta V by delta t equals to dv vector by dt. Instantaneous acceleration is generally called acceleration. Unit meter per second square, dimension L by t square equal to Lt minus 2. Acceleration is a vector quantity. If of course f vector acts on a particle of mass m by Newton's second law, a vector equals to f vector by m. As a vector equal to dv vector by dt, this implies a vector equal to d by dt dr by dt equal to d2r vector by dt square. A particle is moving eastward with a velocity of 5 meters per second. If in 10 seconds the velocity becomes 5 meters per second northward, what is the average acceleration in this time? What is the average acceleration in this time? Because particle is moving eastward with velocity, we consider this is v1 vector, and again it changes its direction into northward, so it is represented by v2 vector. What is the then? Now we can write delta V equals to V2 minus V1, and mode of V1 and mode of V2 is given 5 meters per second. That is magnitude of both velocity is same. Again we can write V2 vector plus minus of V1 vector, and this will represent the delta V vector. Because this is V2, then this will be minus, and triangle, from the triangle law, this will be the resultant of V2 minus V1. So this represents the velocity, change in velocity. Hence delta V vector equal to under root 5 square plus 5 square northwest. If this is 45 degree or this is 45 degree, then this direction is called northwest direction or west north direction. So average acceleration A vector equals to A vector average equal to delta V by delta t 5 by root 2 by 10 meter per second square northwest, or 1 by root 2 meter per second square northwest. Second method, delta V equal to V2 minus V1 equals to mode of V2 j cap minus mode of V1 I cap. Because this is V1, so magnitude into direction represent vector, so V1 into I cap, mode of V1 into I cap, and this is V2, magnitude into direction, so V2 into j cap equals to 5j minus 5I cap meter per second square. Means average delta V by delta t 5j minus 5I cap divided by 10 meter per second square equals to 1 by 2 j cap minus 1 by 2 I cap meter per second square answer. Now magnitude of average acceleration will be under root 1 by 2 square plus 1 by 2 square meter per second square 1 by 2 root 2 equals to 1 by root 2 meter per second square. Question: what does mode of dv by dt and d mode dv by dt represent? Can these be equal? Can mode of v d by dt equals to 0, while mode of dv by dt is not equal to 0. D and mode of v d by dt is not equal to 0, while mode of dv by dt equals to 0. Answer A. Mode of dv by dt is the magnitude of total acceleration. Magnitude of acceleration while d mod dv by dt d by d mod d by dt mod of v d by dt represent the time rate of change of magnitude of velocity, that is a speed, because instantaneous speed is equal to the instantaneous distance is equal to the instantaneous displacement, and this is called the tangential acceleration speed, a component of total acceleration as mode of v equals to v. b These two are equal in case of one dimensional motion without change in direction. See, in case of uniform circular motion, speed remains constant while velocity changes. Hence, mode of v d by dt equals to 0. Speed remains constant, so constant differentiation constant equal to 0, while mode of dv by dt equals to not equal to 0, because velocity changes. Because in this case direction always change, instantaneously also change. D mode of v d by dt is not equal to 0 implies that a speed of particle is not constant. Velocity cannot remain constant if a speed is changing. Hence, mode of dv by dt cannot be 0 in this case. So, it is not possible to have mode of dv by dt equals to 0 and while mode of v d by dt is not equal to 0. Uniformly accelerated motion. When the acceleration of the moving particle remains constant, the motion is called uniformly accelerated. That is, a vector equals to constant. We know that a equals to dv by dt or dv equals to a vector dot dt. This implies integration u vector to v dv equals to a into integration 0 to t dt, because a is constant, so it comes out of the integration, and it is assumed that initial velocity is u and final velocity is v. At t equals to 0, velocity is u, and t equals to t, velocity is v. So integration dv is v. So in the limit u to v equals to a vector into in the limit 0 to t, or v vector minus u vector equals to a vector into t. Hence v vector equals to u vector plus a vector into t. V vector is the final velocity vector, t is the time elapsed, and u vector is the initial velocity vector. In projection form, we can write vxik plus vyjk plus vzk cap equal to uxik plus uyjk plus uzk cap plus axik plus ayjk plus azk cap into t, or equals to ux under bracket ux plus ax into t into I cap plus uy plus ay into t into j cap plus uz into az into t into k cap. Equating the coefficient of ij and k, we get vx equal to ux plus ax into t plus vy equal to uy plus ay into t and vz equal to uz plus az into t. Second, v vector equal to dr by dt, or integration dr from the limit r0 to r vector, v integration of v vector dt from the limit 0 to t equals to 0 to t u vector, because v vector equal to u vector plus at. So u vector plus a vector into t dt. This implies 0 to t u vector into dt plus 0 to t a vector t dt. So differentiation of dr is r in the limit r0 to r equals to u vector into under the limit 0 to t a vector t square by 2 in the limit 0 to t. This implies r vector minus r0 vector equals to u vector into t plus half into a vector into t square, or r vector equal to r0 vector plus u vector into t plus half a vector into t square, where r vector is the final position vector or final position at t equals to t, and r0 is initial position, that is the position of particle or body at t equals to 0. Now displacement vector delta r equal to r naught vector minus r naught vector equals to u vector t plus half a vector into t square. In projection from we can write sx equal to delta x minus x naught equals to ux into t plus half ax into t square. Sy equal to delta y equal to y minus y naught uy t plus half ay t square. Sz equal to delta z minus z naught uz t plus half ay t square. If particle starts moving from origin, then x0 x0 equal to 0, y0 is equal to 0 and z0 is equal to 0. So sx equal to x equals to ux t plus half x t square, sy equal to y equals to uy t plus half ay t square, and sx equal to z uz t plus half az t square. Third, we have v vector equal to u vector plus a vector into t, or v vector dot v vector under bracket u vector plus a vector into t dot u vector plus a vector into t equals to u vector dot u vector plus u vector dot a vector into t plus a vector into t dot u vector plus a vector dot a vector into t square, or u vector dot u vector plus 2u vector dot a vector into t plus a vector dot a vector t square, or u vector dot u vector plus 2a vector dot into u vector t plus half a vector t square, or u vector dot u vector plus 2a vector dot r vector minus r naught vector. If particle starts at origin, then r naught vector equals to 0. Hence v vector dot v vector equals to u vector dot u vector plus 2a vector dot r vector. In projection from vx square equals to vx square is equal to ux square plus 2ax into x. Here v dot v will be v square and u dot v will be a square, but a vector dot r vector will not be, because their direction may be in same direction or in opposite direction. It depends on the situation, but in one dimensional motion like vx, vy, y along yz, the acceleration and displacement vector is same direction. So we are writing this formula: vx square equal to ux square plus 2x into x, or vy square equals to uy square plus 2ay into y, and vz square equal to uz square plus 2az into y, az into z. The particle starts moving from the position 1 minus 2 comma 3 meter with initial velocity u vector 4i cap plus 8j cap minus 6k cap and an acceleration a vector 2i cap minus j cap plus 4 cap meter per second square. Find a the velocity of particle at 2 seconds, b the position and displacement of particle after 4 seconds, and the mean velocity of particle during the 0 to 2 second. Solution: here v vector equal to u vector plus a vector into t. Putting all the value, u vector is 4i cap plus j cap minus 6 cap plus 2i cap minus j cap plus 4 cap into t meter per second. T is given here after 2, so at this into 2. Also 4i cap plus 8j cap minus 6k cap, this will be 2 into 2, 4i cap minus 2 into 1 minus 2j cap plus 4 into 2, 8k cap meter per second, or equals to 8i cap plus 6j cap 4 8i cap 8j minus 2j 6j cap and minus 6k plus 8k plus 2k cap meter per second. This is in the vector form. You can also find magnitude of velocity by taking mode. The displacement of vector r vector minus r naught vector u vector into t plus half a vector into t square. r vector at t is equal to the position and displacement. Here t is 4 second. R vector minus so 4 I cap plus 8 j cap minus 6 k cap into 4 t 1 by 2 I cap minus j cap plus 4 k into 4 square. Solving this, finally we get 32 I cap plus 24 j cap plus 8 k cap meter. Hence position vector equal to r vector equals to r naught vector plus u vector into t plus a half a vector into t square, or r vector equals to, putting r naught vector is this, u vector is this, and half a t square. This value have been calculated. That is the this value is equal to this, so we have put in this equals to 33 I cap plus 22 j cap 3 cap and 11 k cap. So 11 into under bracket 3 I cap 2 j cap plus k cap meter answer. See, the mean velocity of particle during 0 to 3 seconds. Mean velocity equals to average of v, that is delta r by delta t, r2 vector minus r1 vector. This by delta r vector by delta t equal to r vector minus r naught vector, because r1 here given r naught by delta t, or u vector, this is equal to u vector t plus half a vector into t square by delta t. So putting the value 4 I cap plus 8 j cap minus 6 k cap into 2 1 by 2 a value of the a vector and into 2 square by 2 minus 0, because time interval is 2 minus 0, here also 2 minus 0, here also 2 minus 0 to the whole square. We have put it directly, equals to 4 I cap 8 j cap minus 6 cap into 2 plus 2 I cap minus 3 cap plus 4 cap into 2 this 2 is cancelled by 2 or integration of under braces under bracket 4 I cap plus 8 j cap minus 6 cap plus 2 I cap minus j cap plus 4 k cap meter per second equals to 4 plus 2 6 I and 8 minus 7 8 minus 1 7 j and minus 6 plus 4 equal to minus 2 k cap meter per second answer. Taking modulus, we can take the magnitude of velocity vector, that is mode of this will be root under 6 square plus 7 square plus minus 2 square. Now a particle starts from origin with initial velocity of 20 meter per second with direction cosine L equals to 0.4 and m equals to 0.3 and acceleration 10 meter per second square with direction cosine L dash equal to 0. And m dash equal to 0.2. Find the velocity and position of the particle at t equal to c second. Here given cos alpha equal to L equal to 0.4 and L equals to cos alpha, that is direction cosine is cos alpha, Lmn, it is represented by Lmn or cos alpha cos beta cos gamma. Vector makes angle with x coordinate, y coordinate and z coordinate, that is the angle. So L, we know that L equal to cos alpha ux by ui, ux by u. So hence Vx is equal to V into L at 20 into 0.58 meter per second, and similarly Vy equal to U into M 20 into 0.36 meter per second. Hence U vector equal to V vector equal to Vx I cap plus Vy j cap plus 8 I cap plus 6 j cap meter per second. Similarly for acceleration, Ax equal to L dash into A 0.1 into 10 1 meter per second, Ay equal to M dash A 0.2 into 10 2 meter per second. Square A vector x I cap plus Ay j 1 plus 1 I cap plus 2 j cap meter per second. Now V equal to U vector plus A vector into T at T equal to 2 seconds. V vector equal to U vector plus 2A vector 8 I cap plus 6 j cap plus 2 into I plus 2 j cap equals to 10 I cap plus 10 j cap meter per second. Again, R vector equal to U vector into T plus half vector into A vector into T square at T equal to 2 seconds. R vector 2U vector plus half into A vector into 2 square, 2U vector plus 2U, 2A vector or 2 into 8 I plus 6 j cap plus 2 I cap plus 2 j cap meter equals to 18 I cap plus 16 j cap meter in the vector form, in the component form. Next.